So in the last video, we discussed how to factorize algebraic expressions with two terms. And these working outs over here are from the previous class. So as a recap, let's do question number 3. 6x squared plus 12x. So when we are factorizing this expression, we look into each term and figure out what's common in each term. If we look at the coefficients, we understand that 6 is common from the coefficients. So we take 6 out. And from the variable, we see x as a common variable. So we take x out common. So if we take 6x out from the term 6x squared, what remains is just x. Plus, if you take 6x out from the term 12x, what remains is 2. So the factorization of 6x squared plus 12x is 6x within brackets x plus 2. Now, if you didn't understand how this was done, I highly recommend that you watch the previous video as we discussed in detail of how this factorization takes place. Now, in this video, we'll be discussing about factorizing algebraic expressions with 4 terms. For example, let's take the expression 7a squared plus 2ab minus 3ac plus 4ad. Now, if you're factorizing with 4 terms, you would have to find a common factor that is common for all 4 terms. When you look at the numbers, it is 7, 2, -3, and 4, which have nothing in common. But when you look at the variables, you realize that a is common for all of them. So one possible way of doing a factorization for this kind of an expression is to take a out common and then write what's left off from the expression. So that is, if you factor out a from the first term, you only have 7a left. From the second term, a is gone, that's just 2b. From the third term, again a is gone, that's just 3c, and likewise 4d. Now this could be considered a factorization, because when we are saying factorization, what we are really trying to do is to express or write down the given expression in a form of multiplication. And we have achieved that goal here because we've given this as a product of 2 separate algebraic expressions. In this case, it is a times this expression. So this is considered a factorization. However, not all algebraic expressions with 4 terms will have a common factor that is present in all 4 terms. For example, let's have a look at this algebraic expression, mp minus mq negative np plus positive nq. Now, if you have a look at all of these 4 terms, there is no common factor that is common for all 4 terms. Because if you see the first term, it has m and p, and the second term doesn't have p, the first term doesn't have n. So there is something missing, then there is no single variable that you can find that is throughout all the terms. So in this kind of a situation, you don't have a common factor like you did in this previous question over here. So for a question like this, the way you would factorize is not factorize all at once, but factorize pair by pair. So what you would do is you would consider these 2 terms separately and these 2 terms separately. Now you can factorize mp minus mq separately and negative np plus nq separately. And what that means is we're just doing what we did in the previous video, factorizing algebraic expressions with 2 terms. So let's factorize them separately. mp minus mq. M is the only common factor, so I'll take m out. And if I take m out, from the first term, what remains is just p, because you factored out m and the only remaining term would be p, minus, and then what's remaining on the second term would be q. So m times p minus q. And from the second pair, I can see that n is a common factor. So if I take n out, so plus n out, what I'll have inside the bracket is a negative p and a positive q. Alright, so now we've factorized this algebraic expression with 4 terms by taking it as groups of 2 and individually factorizing the pair. So does that mean that this is the answer? Well, not really, because the idea behind factorizing is to be able to write down the algebraic expression as a product of 2 other expressions. So what that means is we have to express this algebraic expression as something times something. But what we've done here is we've expressed the same algebraic expression as something added to something, which is not clearly the idea behind why we factorize. and therefore it cannot be considered as a factorization, because of the main purpose of factorization itself is to express the algebraic expression as a product of two other expressions. So how do we deal with this situation? Well, there is a way to factorize this particular question, but this method doesn't generally apply to any algebraic expression with four terms. So let's look at what that method is. So that method is all about making these two brackets the same. At this moment, they're not the same. The first bracket has the expression p minus q. The second bracket has the expression negative p plus q. They're not the same. But the goal has to be to make them same. So what I'm going to do is I'm going to make a small change in the second pair. Instead of taking positive n out as a common factor, I'm going to take negative n out as a common factor. Now, if I take negative n out as a common factor, what remains is positive p. And if I take negative n as a common factor from the second term doesn't have a negative sign. And therefore, to compensate with the negative that I took out, it has to create another negative sign. So that when you expand this again, you get the original expression. So let's expand this and see. Negative n times p is negative np. Negative n times negative q. Now it becomes positive nq, giving us the same pair that we started with. So one thing to keep in mind in this simplification is that negative times a negative is equal to positive. Therefore, if you take out a negative value from a positive value, that means there is another negative value remaining. For example, if there was a positive 3x and if you factored out a negative x, what you did here is you factored out a negative sign that didn't exist. So the way we would look at this positive 3x now is to look at it as negative times negative 3x, because positive sign is just a multiplication of two negative signs. And since you took negative x out, so one negative and one x has gone out, what's remaining inside is another negative and a 3. So that's negative 3. And that's the reason when you factor out a negative n from a positive nq, you have a negative q inside, you have a new negative sign inside, because to counteract this negative sign that you took out, which was never there in the first place, so that when you expand it back again, negative n times negative q will give you positive nq. Alright, hope that's clear. So now what? We somehow made the brackets same. We have p minus q in our first bracket and also p minus q in our second bracket. So what's the next step now? Well, the next step is to factorize again. Now this time, this entirely is considered as one term, and this entirely is considered as one term, right? So this is again just algebraic expression with two terms. Now the term that is common in both of these is the bracket p minus q. So what I'm going to do is I'm going to take this p minus q bracket as a common factor outside. So if I take p minus q outside, what remains inside will be, from the first term you've already taken p minus q, so there's no more p minus q. The only thing that's remaining is this m, so that m will come inside. And then from the second term again, p minus q is gone, and therefore what's remaining is the negative n, negative n. So the answer is just p minus q within bracket and m minus n within another bracket, and that is the answer. So now we've clearly achieved our goal, and our goal was to factorize. And what factorization means, as I've said previously, is to express an algebraic expression as a product of two other expressions. And we have achieved it. This is a product. This is p minus q times m minus n. So we've expressed mp minus mq minus np plus nq, this expression, as a multiplication of two other expressions. And that's it. That's the answer. So the summary is, when you've been given with an algebraic expression which has four terms, you would separate them into groups of two and then factorize them individually. And when you are factorizing, you have to make sure that the brackets remain the same. And if you can get the brackets the same, then you can proceed into the third step, where you take the bracket term out as the common factor, and whatever that remains will fall into the next bracket, and that's it. You've obtained the factorized version of the expression. Hope you understand how factorization works. In the next video, we'll be looking into some practice questions so that we can get ourselves familiar with factorizing expressions with 4 algebraic terms. If you like this video, hit the like button and subscribe for more similar content. And please feel free to comment below if you have any questions or if you have any topics that you want me to discuss in my next videos. See you in the next video.